Now that we've looked at simplifying rational expressions and solving rational equations, this video is going to take us through some applications for rational equations. So let's look at the first one. It says, in physics, the focal length f of a lens is given by the formula 1 over f equals 1 over p plus 1 over q. In the formula, p is the distance from the object to the lens, q is the distance from the lens to the image, and we know that f is the focal length. So what this is asking us to do is to find q if p equals 20 and f equals 10. So we are going to take our formula right here, and we're going to replace the numbers that we know and then solve for the ones we don't. So we know f, so it's going to be 1 over 10. We know p, 1 over 20, because it's given to us right here. And then we want to solve for 1 over q. Now what makes this different is that the variable that we're solving for is in a denominator. It's a rational expression. So we're going to use the LCD again, just like we've been doing, to clear our fractions of those denominators. So in order to get rid of a 10, a 20, and a q, I need a 20q. So just like before, each term goes in parentheses, and we are going to write the LCD beside it, indicating multiplication. 10 goes into 20 2 times. I have 2 times 1 times q, or 2q. 20 goes into that once, so I have 1 times q is q. Q's cross cancel, and I have a 20. This is a linear equation in one variable. So to solve for q, I get variables on one side, numbers on the other, and I end up with 2q, take away 1q is 1q equals 20. So that was very simple, just to replace variables with numbers that were given. I just wanted to kind of go through that with you to remind you how to use the LCD to clear your denominators. Let's do another one. Same formula, 1 over f equals 1 over p plus 1 over q. But this time we're going to solve it for a specified variable. We're going to solve for p, meaning that there's not going to be numbers that go in. So just like we did in the problem before, in the example before, what we want to do is clear our denominators. And I do that by using the LCD. So in this LCD, I need an F, a P, and a Q. So I'm going to rewrite this so it's a little bit larger, so we have space to put each term in parentheses and then multiply by the LCD. FPQ, FPQ. The F's cross cancel and I get PQ. The P's cross cancel and I get FQ. The Q's cross cancel, don't forget that plus is in there, and I have FP. Now, this is an example of one that we've done in prior videos where the letter that I'm looking for occurs twice. So what I have to do is to get the terms that contain that variable on the same side of the equation. So I'm going to subtract an FP. That gives me PQ minus FP equals FQ. And now our goal is to go from having 2 of the specified variables down to 1. And if you'll remember, the way that we did that is to factor out, and I think I'm going to bring this up here and do it, factor out the specified variable. What's left is Q minus F equals FQ. So I have just gone from having 2 of the specified variables, 2 terms with a P, down to just having 1. And that has to happen before you can solve for that variable. Now all that's left to do is to divide by the coefficient of the specified variable. And you get P equals FQ over Q minus F. Solving for a specified variable. All right, let's look at example 3. Here I want to solve for n, and what I have is I equals n e over r plus nr. Now I'm looking for n, and you can see it occurs 2 places, once here and once here. But I've got to get rid of this denominator first. So the first thing I'm going to do is multiply by the LCD. Well, there's only one denominator, so that has to be my LCD. But I multiply by that on both sides. This cross cancels. I'm left with I times r plus n little r equals NE. Now I can see here's one of the variables I'm looking for, but the problem is here's another one in parentheses. To get it out of the parentheses, I'm going to distribute the I, so I get IR plus INR equals NE. And now we're back to about where we were right here, where the letter that I'm looking for occurs twice, and I need to get those on the same side. So I'm going to do that by subtracting the I in R. That gives me I capital R equals NE minus I N R. Now I have 2 of them, and to go to having just one, I factor that specified variable out, leaving me, and I change sides here, sorry about that, IR equals, I didn't mean to do that. So we factored out an N, I'm left with an E here and an IR here, and it's equal to IR. Now the only thing left to do is to divide by the coefficient of the specified variable, E minus IR. And I know there's a lot of letters here, I get it. N equals IR over E minus I little r. I want you to notice something. One of the keys to knowing you have the answer is that the specified variable, in this case this n, only appears one time, and it's n equals. There's no little n over in the rest of it. Let's look up at this one. I was looking for p. It's the only p in the answer. There's no letter p, the variable p, in any of the remainder. That's how you know when you have solved for that variable correctly.